Hello, good morning, students. In the last video, we have discussed up to this problem. Now coming to the next problem. If capital A and capital B are two events, then show that P of A minus B is equal to P of A minus P of A intersection B. So already we have discussed this part in addition theorem. So from the diagram, so this is the A minus B part and this is B minus A and this is A intersection B. Since A and B are two events from the figure, A is the union of regions A minus B and A intersection B. This A can be written as A minus B union A intersection B. And also A minus B and A intersection B are mutually disjoint or mutually exclusive. Therefore, P of A can be written as P of A minus B plus P of A intersection B. P of A can be written as P of A minus B plus P of A intersection B. Now taking P of A intersection B into right side, we get P of A minus B is equal to P of A minus P of A intersection B. So that is the end of proof. P of A minus B is equal to P of A minus P of A intersection B. So as it is as it is in addition theorem. Next, fifth problem. If capital A and capital B are two events, then show that the probability that exactly one of them occurs is given by P of A plus P of B minus 2 into P of A intersection B. So దీని గురించి కూడా మనం set theoretic notations లో representation ఇచ్చాం already. Exactly one of the events A and B occurs means A intersection B bar union B intersection A bar. Solution: given A comma B are two events, exactly one of A comma B occurs is denoted by A intersection B bar or A bar intersection B. For required probability is equal to P of A intersection B bar plus P of A bar intersection B. From figure, A is the union of regions. There is A intersection B bar, comma A intersection B. So therefore, P of A can be written as P of A can be written as P of A intersection B bar plus P of A intersection B. It is already proved in the previous problem. P of A can be written as P of A intersection B bar union A intersection B. That is P of A intersection B bar plus P of A intersection B. From this we can write P of A intersection B bar is equal to P of A minus P of A intersection B. Let it be equation 1. Next one. From the figure again, B can be written as union of two regions, that is A intersection B and A bar intersection B. Then B is equal to, B can be written as A intersection B union A bar intersection B. Therefore, B can be written as P of B is equal to P of A intersection B union A bar intersection B. And also A intersection B and A bar intersection B are mutually exclusive regions. So therefore, union of the probabilities is equal to sum of their probabilities. That is P of A intersection B plus P of A bar intersection B. That is P of B minus P of A intersection B is equal to P of A bar intersection B. Therefore, P of B minus P of A intersection B is equal to P of A bar intersection B. P of A bar intersection B is equal to P of B minus P of A intersection B. Now substitute 2 and 3 in 1 gives required probability is equal to P of A minus P of A intersection B plus P of B minus P of A intersection B. So this is equal to P of A plus P of B minus 2 into P of A intersection B. So this is the proof of probability of exactly one of the events occurs. There is a P of A plus P of B minus 2 into P of A intersection B. So the set theoretic notation is A intersection B bar or A bar intersection B. Then the probability of the union of the two events is P of A plus P of B minus 2 into P of A intersection B. We can also use this formula to find the exactly one of the events to happen. Next one, for any two events A and B, show that P of A complement intersection B complement is equal to 1 plus P of A intersection B minus P of A minus P of B. So A complement intersection B complement means A bar intersection B bar. So P of A complement intersection B complement is equal to P of A bar intersection B bar. So this event also can be written as P of A union B whole bar. This is just like a P of A bar laga undi. So P of A bar kabatti there is 1 minus P of A raskochu. That is 1 minus P of A union B. Now write the value of P of A union B by using addition theorem. That is equal to 1 minus of P of A plus P of B minus P of A intersection B. So by multiplying this bracket with the negative sign, that is 1 minus P of A minus P of B plus P of A intersection B. Write in the order, that is 1 plus P of A intersection B minus P of A minus P of B. So this is the proof. Now coming to short answer problems. Short answer problems. First one, let A and B are seeking admission into IIT. If the probability for A to be selected is 0.5 and that of both to be selected is 0.3, is it possible that the probability of B to be selected is 0.9? చూడండి క్వశ్చన్ ఒకసారి క్లియర్గా అర్థం చేసుకోండి. So A and B are seeking admission into IIT. That means they are trying to get admission into IIT. If the probability for A to be selected is 0.5 and that of both to be selected is 0.3, is it possible that probability of B to be selected is 0.9? That means let capital A comma define the events first. Let capital A comma capital B be the events of getting admission by the students A comma B respectively. And the students A B ఇచ్చారు కాబట్టి సో ఈవెంట్స్ కూడా నేను అలాగే డిఫైన్ చేసుకుంటున్నా, లేదా E1 కామా E2 బి ద ఈవెంట్స్ అని డిఫైన్ చేసుకోవచ్చు, నో ప్రాబ్లం. ఏబి ఈవెంట్స్ ని కూడా మనం ఏబి అని డినోట్ చేస్తే ఏ అనేది ఈవెంట్ కరస్పాండింగ్ టు ద స్టూడెంట్ ఏ, బి ద ఈవెంట్ దట్ ద స్టూడెంట్ కరస్పాండింగ్ టు బి అవుతుంది. సో అప్పుడు సింపుల్గా అంటే కన్ఫ్యూజన్ లేకుండా ఏ స్టాండ్స్ ఫర్ స్టూడెంట్ ఏ, బి స్టాండ్స్ ఫర్ స్టూడెంట్ బి, మీకు క్లారిటీ ఉంటుందని నేను అలా అజ్యూమ్ చేసుకున్నాను. లెట్ ఏ కామా బి బి ద ఈవెంట్స్ ఆఫ్ గెటింగ్ అడ్మిషన్ బై ద స్టూడెంట్స్ ఏ కామా బి రెస్పెక్టివ్లీ. గివెన్ probability for A to be selected is 0.5. Therefore, P of A is equal to 0.5. Next, and that of both to be selected is 0.3. And both A and B will happen ante then A intersection B to denote chestam event ni. And P of A intersection B is equal to 0.3. This is the given data. Now we have to verify whether the probability of B to be selected is 0.9 or not. Is it possible or not? So for this, let us consider P of, we know that P of A union B always less than or equal to 1. That means probability of any event less than or equal to 1. Clearly, probability of any event lies between 0 and 1. So for this, we are considering P of A union B less than or equal to 1. That means P of A plus P of B minus P of A intersection B less than or equal to 1. Now substitute the values of P of A and P of A intersection B. That is 0.5 plus P of B minus 0.3 less than or equal to 1. 0.5 minus 0.3 and 0.2. 0.2 right side తీసుకెళ్ళండి. That implies P of B less than or equal to 1 minus 0.2. That implies P of B less than or equal to 0.8. That means in this case, probability of B to be selected is less than or equal to 0.8. So therefore, probability of B to be selected is 0.9 is not possible. Therefore, P of B equal to 0.9 is not possible. That means probability of B always less than or equal to 0.8. That never takes the value 0.9. Now coming to next problem. Find the probability of drawing an ace or a spade from a well-shuffled pack of 52 cards. ఏస్ ఆర్ స్పేడ్ చూడండి, ఇక్కడ ఎప్పుడైతే 2 ఈవెంట్స్ మధ్యలో ఆర్ ఇచ్చేసారో ఇమీడియట్గా మీకు ఎడిషన్ థియరం ప్రాబ్లం అనేది మీకు ఐడియా రావాలి. దట్ మీన్స్ వెన్ ఏ కార్డ్ ఈజ్ డ్రాన్, what is the probability of getting ace card or spade card? మరి ప్రాబబిలిటీ ప్యాక్ ఆఫ్ కార్డ్స్లో ఏస్ కార్డ్స్ ఎన్ని ఉంటాయి, స్పేడ్ కార్డ్స్ ఎన్ని ఉంటాయి మీకు తెలుసు. ఏస్ కార్డ్స్ 4 ఉంటాయి, అంటే ఏ సింబల్తో ఉండేటువంటి కార్డ్స్. అలాగే స్పేడ్ కార్డ్స్ అంటే సూట్ గురించి మెన్షన్ చేస్తున్నారు ఇక్కడ, దట్ ఈస్ 13 కార్డ్స్ ఉంటాయి. అలాగే స్పేడ్ ఏస్ ఒకటి ఉంటుంది, స్పేడ్ ఏస్ ఒకటి, క్లబ్ ఏస్ ఒకటి, హార్ట్స్ ఏస్ ఒకటి, డైమండ్ ఏస్ ఒకటి ఉంటుంది. సో అలా ఒక్కొక్క సూట్కు సంబంధించి ఒక కార్డు ఒకటి, ప్రతి ఒక్కటి ఒకటి ఉంటుంది మనకి. రైట్, సో ఫస్ట్ let E1, E2 be the events of drawing an ace card, spade card respectively. So required probability is equal to P of E1 or E2. That is P of E1 union E2. A value మనం find out చేయాలి. To find the value of P of E1 union E2, so we have to find the values of P of E1 and P of E2 and P of E1 intersection E2 also. So but P of E1 is equal to probability of drawing an ace, that is equal to, so we have total 52 cards, that is N of S is the 52C1, and also we have only 4 aces in the pack of 52 cards. If you draw an ace, you can get any one ace. So there is a probability of drawing an ace is equal to 4C1 by 52C1. That is equal to 4 by 52. Also P of E2 is equal to probability of drawing a spade card. So spade cards 13 ఉంటాయి కాబట్టి, so then probability 13C1 by 52C1. That is equal to 13 by 52. Now E1 intersection E2. E1 intersection E2 means when a card is drawn, it is the event of getting ace of spades or spade ace simply. We have P1 intersection, P of E1 intersection E2 is equal to probability of drawing ace and spade. So we are drawing only one card and it should be of ace of spades or spade ace. That is the probability of drawing spade ace card, that is equal to 1C1 by 52C1, that is 1 by 52. So from addition theorem, P of E1 union E2 is equal to P of E1 plus P of E2 minus P of E1 intersection E2. So that is equal to 4 by 52 plus 13 by 52 minus 1 by 52. So that is equal to 16 by 52, that is 4 by 13. సో ఇక్కడ మీరు P of E1 intersection E2, జస్ట్ E1 intersection E2 ఈవెంట్ని డిఫైన్ చేయండి. E1 intersection E2 is equal to ఈవెంట్ ఆఫ్ గెటింగ్ స్పేడ్ అండ్ ఎస్ అని రిప్రజెంట్ చేసేసి దేర్ ఫోర్ P of E1 union E2 is intersection E2 వాల్యూ డైరెక్ట్గా వేయచ్చు. ఇక్కడ కంపల్సరీగా ప్రాబబిలిటీ ఆఫ్ డ్రాయింగ్ స్పేడ్ అనే కార్డ్ ఇలా రాయక్కర్లేదు. డైరెక్ట్గా మనకి E1 ఇంటర్సెక్షన్ E2 డిఫైన్ చేయండి. ఫస్ట్ డిఫైన్ చేస్తే అప్పుడు ఈ వర్డ్స్ రాసే పని లేదు మనం ఇక్కడ. ఈవెంట్ డిఫైన్ చేయలేదు అనుకోండి, ఇక్కడ ఉన్నట్లుగా రాసుకోవాలి మీరు. సో ఇక్కడ మనకి ఒక సూట్ అండ్ ఒక కార్డు మెన్షన్ చేస్తున్నారు అక్కడ. ఏస్ ఆర్ స్పేడ్ కార్డ్ అంటున్నారు. అలాగే క్వీన్ ఆర్ హార్ట్ కార్డ్ అన్నారు అనుకోండి, సేమ్ ఆన్సర్ 4/13. When a card is drawn from a pack of 52 cards, what is the probability of getting spade or queen, spade or king, spade or jack? Like what is when a card is drawn at random, what is the probability of getting heart or king, heart or queen, heart card or jack card? ఇలా ఒక సూటు ఒక కార్డు మెన్షన్ చేసి ఏదర్ ఏ ఆర్ బి జరగడానికి ప్రాబిలిటీ ఎంత అని అడిగినప్పుడు ఎప్పుడు కూడా ఆన్సర్ 4/13 వస్తుంది. 4/13 అంటే నంబర్ ఆఫ్ ప్రాబ్లమ్స్ కి సేమ్ ఆన్సర్ 4/13 వస్తుంది మనకి. అంటే ఆల్మోస్ట్ 52 టైప్స్ ఆఫ్ ప్రాబ్లమ్స్ కి సేమ్ ఆన్సర్ 4/13 వస్తుంది. 52 ప్రాబ్లమ్స్ కి. Next, in a class of 60 boys and 20 girls, half of the boys and half of the girls know cricket. Find the probability of the event that a person selected from the class is either a boy or a girl who knows cricket. చూడండి ఇక్కడ మనం సెలెక్ట్ చేసుకున్నటువంటి పర్సన్ బాయ్ లేదా క్రికెట్ తెలిసినటువంటి గర్ల్ అవ్వటానికి ప్రాబిలిటీ ఫైండ్ అవుట్ చేయమంటున్నారు. అంటే ఇక్కడ మనకి అగైన్ 2 ఈవెంట్స్ ఇస్తున్నారు. బాయ్ లేదా క్రికెట్ తెలిసినటువంటి గర్ల్ అవ్వటానికి ప్రాబిలిటీ అంటున్నారు కాబట్టి సేమ్ అగైన్ డిఫైన్ ద ఈవెంట్స్. గివెన్ దట్ క్లాస్ consists of 60 boys and 20 girls, total 80 students. Number of girls who knows cricket is equal to 10. ఎందుకంటే మనకి half of the boys and half of the girls knows cricket అన్నారు. మనకి ఇక్కడ సెకండ్ ఈవెంట్ ఏ గర్ల్ హూ నోస్ క్రికెట్ అని అడుగుతున్నారు కాబట్టి అంటే క్రికెట్ తెలిసిన గర్ల్ రావాలి సెకండ్ ఈవెంట్ లో. మరి టోటల్లీ have 20 girls. Out of this, half of the girls knows cricket. That means the number of girls who knows cricket is equal to 10. Now define the events. Let E1 is equal to event of selecting a boy. Then P of E1 is equal to like E2 event of selecting a girl who knows cricket. Then P of E1, that means if we select a person, what is the probability that it is a boy? That is 60C1/80C1, that is 60/80. And P of E2, that means if we select a person, what is the probability that it is a girl who knows cricket? So we have only 10 girls who knows cricket. That is probability to get a person who to get a girl who knows cricket is equal to 10C1/80C1. That is equal to 10/80. Now E1 intersection E2. What is E1 intersection E2 denotes? That means E1 event of getting boy, E2 event of getting girl who knows cricket. Then E1 intersection E2 is a boy and a girl who knows cricket. When we are selecting one person, is it possible it is a boy and a girl who knows cricket? It is never possible, because we can get either a boy or a girl, but not both at a time in a single person. So that's why here E1, the events E1 and E2 are mutually exclusive. That is E1 intersection E2 is equal to 5. E1 intersection E2 equal to boy and a girl who knows cricket. When we are selecting one person, the boy and girl is not possible to get. Therefore, E1 intersection E2 is equal to 5. That implies P of E1 intersection E2 is equal to P of 5, that is equal to 0. From addition theorem, required probability is equal to P of E1 union E2, that is equal to P of E1 plus P of E2 minus P of E1 intersection E2. that is equal to 60 by 80 plus 10 by 80 minus 0, that is 70 by 80, that is equal to 7 by 8. So this is the required probability. సో అక్కడ ఈవెంట్స్ డిఫైన్ చేసుకున్నప్పుడు ఏఆర్బి అనగానే మళ్ళీ మనకి ఏ ఇంటర్సెక్షన్ బి క్యాలిక్యులేట్ చేయడం తెలియాలి. అలా పర్ఫెక్ట్గా తెలిస్తేనే మీకు, అంటే మనం సెలెక్ట్ చేసుకుంటే సింగిల్ పర్సన్ని, ఆ సింగిల్ పర్సన్ బాయ్ అండ్ గర్ల్ రెండిట్లాగా ఎలా యాక్ట్ చేస్తారు? పాసిబుల్ కాదు. అది ఒక పర్సన్ సెలెక్ట్ చేసుకుంటే ఇట్ ఈస్ ఎయిదర్ ఏ బాయ్ ఆర్ ఏ గర్ల్, దట్స్ ఆల్, బట్ నాట్ బోత్ ఎట్ ది సేమ్ టైం. So that's why here E intersection E1 intersection E2 is equal to 5. Next, coming to the next problem. A, B, C are 3 horses in a race. The probability of A to win the race is twice that of B, and the probability of B is twice that of C. What are the probabilities of A, B, and C to win the race? So very, very important problem in IP point of view. So it may be given to 4 marks or 7 marks. Very, very important problem. సో ఇక్కడ క్వశ్చన్ క్లియర్గా అర్థం చేసుకోండి అందరూ కూడా. ఏబిసి ఆర్ 3 హార్సెస్ ఇన్ ఏ రేస్. ద ప్రాబిలిటీ ఆఫ్ ఏ టు విన్ ద రేస్ ఈజ్ ట్వైస్ దట్ ఆఫ్ బి, and the probability of B is twice that of C. That means here for the horses A, B, C, so they are not able to win the race at the same time. No 2 horses will win the race at the same time, because all the horses have different probabilities of chance of winning, because probability of A to win the race is twice that of B. So no 2 horses have the same probability to win the race. That means only 1 horse will win the race. That means so event of winning both the horses, the race is not possible. That means the events, if we define the events A, B, C are the, let A, B, C be the events that the race won by the horses A, B, C respectively. Immediately we can say that the events A, B, C are mutually exclusive. This is an important point in this topic, in this problem. Events A, B, C are mutually exclusive because no 2 horses will win the race have different chance of winning or different probabilities of winning. They don't have equal probability of to win the race. Say that only one or B or C, but not both, or but not at 3 at a time. So the events A, B, C are mutually exclusive. So from the given data, that is the probability of A to win the race is twice that of B. That means P of A equal to 2 into P of B. Given next, P of C, B is equal to 2 into P of C. That means the probability of B is twice that of C. So from this we can write P of B is equal to 1 by 2 into P of A. Let it be equation 1. Again, P of C is equal to 2 into P of B, 1 by 2 into P of B. Now substitute the value of P of B in this equation. We get P of C is equal to, substitute 1 into, that implies P of C is equal to 1 by 2 into P of B value 1 by 2 P of A, 1 by 2 into 1 by 2 P of A. So that is equal to 1 by 4 into P of A. So that means we got all the values of B and probability of B and probability of C in terms of probability of A. Now S is equal to A or B or C. That means here we have only 3 horses which are participating in the race. So therefore the A, B, C are the, so definitely exactly one of the horses will win the race. So therefore, the events A, B, C are mutually exclusive and exhaustive events because no other horse in the race. So definitely, so only one of the among these three horses will win the race. Therefore, S is equal to A or B or C. That means A union B union C. Then P of S is equal to P of A union B union C. But P of S is always 1. That means probability of sample space always 1. So therefore, since A, B, C are mutually exclusive events, then union probability is equal to sum of their probabilities. That is P of A plus P of B plus P of C is equal to 1. Now substitute the values of P of B and P of C in this equation. So from 1, 3 and 4, P of A plus P of 1 by 2 P of A plus 1 by 4 P of A equal to 1. By taking P of A as common, we get 1 plus 1 by 2 plus 1 by 4 into P of A is equal to 1. So LCM తీసుకోండి, that is 4 is the LCM. That is 4 plus 2 plus 1 by 4, that is 7 by 4 into P of A equal to 1. Then P of A is equal to 4 by 7. P of A value 4 by 7. Next P of B కనుక్కోవాలి. P of B అంటే 1 by 2 P of A. అంటే 1 by 2 into 4 by 7 రాసుకుంటే that is 2 by 7 అవుతుంది. From 1, P of B equal to 1 by 2 P of A, that is 1 by 2 into 4 by 7. That implies P of B equal to 2 by 7. Next, P of C is equal to 1 by 4 into P of A. That is 1 by 4 into 4 by 7. That implies P of C is equal to 1 by 7. So therefore, P of A, P of B, P of C are 4 by 7, 2 by 7, 1 by 7 respectively. So these are the respective probabilities of the winning horses to win the race. So very important problem students, అందరూ కూడా పర్ఫెక్ట్ గా ప్రాక్టీస్ చేయండి. జస్ట్ మెయిన్ కాన్సెప్ట్ ఏంటి అంటే, సో ఇక్కడ గేమ్ లో ఓన్లీ 3 హార్సెస్ ఉన్నాయి. సో డెఫినెట్గా ఏదో ఒక హార్స్ విన్ అవ్వాలి, ఏదో ఒకటే విన్ అవుతుంది. సో ఏ రెండు కూడా సైమల్టేనియస్ గా గేమ్ లో ఆ రేస్ ని విన్ అవ్వలేవు, ఎందుకంటే దే హ్యావ్ డిఫరెంట్ ప్రాబబిలిటీస్ టు విన్ ద రేస్. No two horses have the same chance of winning. That's why exactly one of the horse will win the race, that is either A or B or C, but not both or but not 3 at a time. That's why the events A, B, C are mutually exclusive and exhaustive. ఎగ్జాస్టివ్ అంటే యూనియన్ ఆఫ్ ద ఈవెంట్స్ శాంపుల్ స్పేస్కి ఇక్కడ అవుతుంది. ఎందుకు ఎగ్జాస్టివ్ అంటున్నాము అంటే, సో మనకి గేమ్లో ఉన్నది 3 హార్సెసే కాబట్టి డెఫినెట్గా ఈ మూడిటిలోనే ఏదో ఒకటి విన్ అవ్వాలి. సో వేరే హార్స్ విన్ అవ్వడానికి ఛాన్స్ లేదు ఇక్కడ. సో దట్స్ వై ద ఈవెంట్స్ ఏబిసి ఆర్ మ్యూచువల్లీ ఎక్స్క్లూజివ్ అండ్ ఎగ్జాస్టివ్ ఈవెంట్స్ అంటున్నాం. సో అనగానే మీకు ఐడియా, ఎస్ ఈక్వల్ టు ఏ యూనియన్ బి యూనియన్ సి రాసుకొని పి ఆఫ్ ప్రాబబిలిటీ అప్లై చేసుకుంటే మనకు రిలేషన్ వచ్చేస్తుంది. ఆల్మోస్ట్ డేటా అంతా కూడా ప్రాబ్లంలోనే ఇచ్చేసారు వాళ్ళు, అది జాగ్రత్తగా ఆ ప్రాబబిలిటీ రిలేషన్స్ రాసుకొని దీనిలో సబ్స్టిట్యూట్ చేసుకుని సరిపోతుంది. నెక్స్ట్ ఫిఫ్త్ వన్, ఇన్ ఏ కమిటీ ఆఫ్ 25 members, ఈచ్ మెంబర్ ఈజ్ ప్రొఫిషియంట్ ఎయిదర్ ఇన్ మ్యాథమెటిక్స్ ఆర్ ఇన్ స్టాటిస్టిక్స్ ఆర్ ఇన్ బోత్, మ్యాథమెటిక్స్ ఆర్ ఇన్ స్టాటిస్టిక్స్ ఆర్ ఇన్ బోత్. If 19 of these are proficient in mathematics, 16 in statistics, find the probability that a person selected from the committee is proficient in both. So total committee members we have 25. So out of these 25 members, every person, that means 25 persons are efficient or proficient either in mathematics or in statistics or in both. But we are given 19 of these are proficient in mathematics, 16 are in statistics. Find the probability that a person selected from the committee is proficient in both. That means here we are given only two events, that is a proficient in mathematics, proficient in statistics. Now let us define the events. So given that a committee consists of 25 members, each member is a proficient either in maths or in statistics. Therefore, A union B, that is, let A comma B be the events that a person selected from the committee is a proficient in mathematics, comma, statistics respectively. Therefore, A union B, N of A union B 25 అవుతుంది. ఎందుకంటే total committee 25, everyone is proficient either in maths or in stats or in both. Therefore, N of A union B 25, hence P of A union B is equal to 20 N of A union B by N of S. N of S అంటే ఆల్రెడీ కమిటీలో ఉన్నది కూడా 25. So 25 by 25, that is 1. That is the main condition we are given. Next one, 19 of these are proficient in mathematics. That means if a member is selected from the committee, probability of getting a person who is proficient in mathematics is 19 by 25. But 19 are proficient in maths and 16 are proficient in statistics. Therefore, P of A equal to 19 by 25 and P of B equal to 16 by 25. Therefore, required probability is that is, if a person selected from the committee, what is the probability that it is proficient in both mathematics and statistics? That means the required probability is P of A intersection B. Required probability is P of A intersection. So we are given P of A and B, P of A and P of B. So by addition theorem, by using addition theorem, we can find the value of P of A intersection B. So the required probability is equal to P of A intersection B, that is equal to P of A plus P of B minus P of A union B. That is a 19 by 25 plus a 16 by 25 minus 1. Or you can write a 25 by 25. So by taking LCM, we get 25 is the LCM, that is a 19 plus 16 minus 25. So 19 plus 16 becomes 35 minus 25, that is a 10 by 25, that is a 2 by 5. So that is the required probability. Now coming to sixth problem. If one ticket is randomly selected from tickets numbered 1 to 30, then find the probability that the number on the ticket is a multiple of 5 or 7, a multiple of 3 or 5. So again, manaki ikkada 3, 5 or 7. That means we are selecting one ticket. So it is a multiple of 5 or 7. అలాగే it is a multiple of 3 or 5 అవటానికి probability find out చేయమంటున్నారు. సో అగైన్ ఇక్కడ మనకి 2 ఈవెంట్స్ డిఫైన్ చేస్తున్నారు. అంటే మనం చేస్తున్నది ఒక టికెట్, అది మల్టిపుల్ ఆఫ్ 5 ఆర్ మల్టిపుల్ ఆఫ్ 7 అవటానికి probability find out చేయమంటున్నారు. So again we are given 2 events. Now let us define the 2 events. Let A comma B. So given that 30 tickets are numbered 1 to 30, one ticket is selected at random, then N of S is equal to 30 C1, that is equal to 30, that is fixed for any type of operation. Next, let A comma B be the events that the ticket is a multiples of 5 comma 7 respectively. That means A is the event of getting a ticket which is a multiple of 5, B be the event of getting a ticket which is a multiple of 7. Then the set A can be written as, that means the event A can be written as, and A is multiples of 5. So among 1 to 30, the multiples of 5 are 5, 10, 15, 20, 25, 30. That means there are 6 numbers which are multiple of 5 in 1 to 30. Therefore, if a number is selected at random from that 1 to 30 numbers, probability to get it is a multiple of 5 is 6 by 30 అవుతుంది. Next, okay. Next B. ఈవెంట్ రాసుకోండి. బి అనేది మల్టిపుల్ ఆఫ్ 7. మరి 1 to 30లో మల్టిపుల్ ఆఫ్ 7 అంటే అప్పుడు సెవెంత్ టేబుల్ చదువుకోవటమే. 7 1 is 7, 7 2 are 14, 7 3 are 21, 7 4 are 28. అంటే 4 నంబర్స్ ఉన్నాయి. దట్ ఈస్ 7, 14, 21, 28. So therefore P of A is equal to N of A by N of S, that is 6 by 30. That is atla uncheseyanడి. Next N of P of B, that is 4 by 30. So we have to get probability that it is a multiple of 5 or 7. That means A or B, probability of A or B find out cheyali. That is the probability of A union B find out cheyali. But probability of A union B find out cheyalante we should have P of A intersection B also. So from these two sets, A intersection B calculate చేసుకుంటే మనం there is no common elements for these two sets. Therefore A intersection B is equal to 5. Then P of A intersection B is equal to P of 5, that is 0. Therefore required probability is equal to P of A union B, that is equal to P of A plus P of B minus P of A intersection B. That is 6 by 30 plus 4 by 30 minus 0. That is the 10 by 30, that is equal to 1 by 3. Next, second bit. So when a ticket is selected at random, what is the probability that it is a multiple of 3 or 5 అన్నారు. Again define the events. Let A comma B be the events that the ticket is a multiple of 3 comma 5 respectively. Now write the set A. That means write the multiples of 3 in set A. Now third table చదువుకోండి. 3 1s are 3, 3 2s are 6, 3 3s are 9, and so on. 3 10s are 30. So totally we have 10 elements in set A. Similarly, elements in set B, there is fifth table. There is a 5 1 is 5, 5 2s are 10, and so on. 5 6s are 30. That means 6 elements are there in set B. 10 elements are there in set A. Therefore, P of A is equal to 10 by 30. P of B is equal to 6 by 30. Again, A intersection B. A intersection, here A intersection B will exist. That means the common elements for these two sets is that is 15 and 30. Here A intersection B is equal to a set of elements 15 and 30. So that is P of A intersection B is equal to 2 by 30. Required probability is equal to P of A union B, that is equal to P of A plus P of B minus P of A intersection B. So that is equal to 10 by 30 plus 6 by 30 minus 2 by 30. So that is a 10 plus 6 minus 2 by 30, that is a 14 by 30, that is 7 by 15. So this is the probability to get a ticket which is a multiple of 3 or 5 when a ticket is drawn at random from the tickets numbered 1 to 30. Now coming to next problem, that is problem number 7. If P of A equal to 0.3, P of B is equal to 0.4, P of C equal to 0.8, P of A intersection B is equal to 0.08. P of A intersection C is equal to 0.28, P of A intersection B intersection C equal to 0.09, and P of A union B union C is greater than or equal to 0.75. Then show that P of B intersection C lies in closed interval 0.23, 0.48. So very simple problem. So already మనం ప్రీవియస్ వీడియోలో P of A union B union C ప్రూఫ్ కూడా చేసుకున్నాం మనం. సో ఆ ఫార్ములా అప్లై చేసుకుంటే సరిపోతుంది మనకి. సొల్యూషన్. So we know that P of A union B union C less than or equal to 1. That means the probability of any event always less than or equal to 1. That's why we are using P of A union B union C less than or equal to 1. And also we are given P of A union B union C greater than or equal to 0.75. That means P of A union B is greater than or equal to 0.75 and less than or equal to 1. That means 0.75 less than or equal to P of A union B union C less than or equal to 1. That is the main given condition. Now write the formula for P of A union B union C. That is P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C, which is less than or equal to 1. Now substitute all these values except P of B intersection C. We are given all the remaining values. That is 0.75 less than or equal to P of A, that is 0.3 plus 0.4 plus 0.8 minus 0.08 minus minus P of B intersection C minus 0.28 plus 0.09 less than or equal to 1. So values అన్ని substitute చేసుకోండి. Now simplify it. 0.3, 0.4, 0.8. So this is a 1.5 and plus 0.09, there is a 1.59. 1.59 minus 0.28. 1.59 minus 0.28, we get 1.23. Minus P of B intersection C, write as it is. And 0.75 and 1 also write as it is. But we want to find P of B intersection C. So by multiplying with minus 1 throughout the inequality, we get minus 0.75 greater than or equal. By multiplying with the negative sign, the inequality will be reversed. That is greater than or equal to P of B intersection C minus 1.23 is greater than or equal to minus 1. Now we have to find only P of B intersection C. So to eliminate minus 1.23, add 1.23 throughout this inequality. So that is 1.23 minus 0.75 greater than or equal to P of B intersection C is greater than or equal to 0.23. So finally this is 0.48. So that is 0.48 greater than or equal to P of B intersection C greater than or equal to 0.23. That means 0.23 less than or equal to P of B intersection C less than or equal to 0.48. Therefore, P of B intersection C lies between 0.23 and 0.48. Hence proved. Now coming to the last problem of this exercise. If A, B, C are 3 newspapers published from a city, 20% of the population read A, 16% read B, 14% read C, 8% read both A and B, 5% read both A and C, 4% read both B and C, and 2% read all the 3. Find the percentage of the population who read at least one newspaper. So this is also an important problem in IP point of view. That is for 7 marks. Okay, let us see the solution. So first of all, here we are 3 newspapers. That's why we have to define 3 events. Let A, B, C be the events that a person reads the newspapers A, B, C respectively. Therefore, P of A is equal to, given we are given 20% of the population read A. That means if a person selected at random from that population, probability that he reads newspaper A, that is a 20%, that is a 20 by 100. 20% of the population reads newspaper A. So that's why if a person chosen at random, probability that he reads A, the newspaper A is 20 by 100. Similarly, 16% read B. That means P of B equal to 16 by 100. 14% read C. That's why P of C equal to 14 by 100. Next, 8% read both A and B. That means if a person selected at random, the probability that he reads both the newspapers A and B, that is 8%, that is 8 by 100. Similarly, 5% read both A and C. That means P of A intersection C is 5 by 100, and a P of 4% read both B and C, then P of B intersection C is equal to 4 by 100. Next, and 2% read all the three. That means P of A intersection B intersection C is equal to 2 by 100. So this is the given data. So find the percentage of population who read at least one newspaper. That means we have to find the probability. First of all, we have to find the probability of A or B or C. That means P of A union B union C find out చేయాలి మనం. మరి P of A union B union C అంటే P of A plus P of B plus P of C minus P of A intersection B minus P of A intersection C minus P of B intersection C plus P of A intersection B intersection C. మరి all values we are given. So just write the formula and substitute all these values, we get the required probability. So probability that the person reads at least one newspaper is equal to P of A union B union C. There is nothing but P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. That is 20 by 100 plus 16 by 100 plus 14 by 100 minus 8 by 100 minus 4 by 100 minus 5 by 100 plus 2 by 100. So take LCM, that is 100 is the LCM. That is 20 plus 16 plus 14 minus 8 minus 4 minus 5 plus 2. So this is 16 plus 14, 30, 30 plus 20, 50 plus 2, 52, 52 minus 17. That is 35 by 100. That means, so out of 100, 35% will read at least one newspaper. That means the percentage of the population reads at least one newspaper is equal to 35%. So this is the answer. That is, they are asking only not probability that a person read at least one newspaper. They are asking percentage of population. That means 35% of the population reads at least one newspaper. Therefore, 35% population reads at least one newspaper. So, okay, students, this is the end of this exercise. So, next video lo manam conditional probability. So, alage multiplication theorem and probability, alage Bayes theorem, and also applications of those theorems we'll discuss in the next video. So until then, watch these videos and get a full of confidence on these two exercises. Okay, thank you.